Here we're going to talk about three common functional groups in organic chemistry, sometimes more in organic chemistry too, which are aldehydes, ketones, and carboxylic acids. And for an aldehyde, essentially we need in our molecule somewhere a carbon that is double bonded to an oxygen and single bonded to a hydrogen. And we'll take our suffix at the end of our molecule and change the suffix to Al. For example, from methane to methanal. If we have a ketone, that is specifically a carbonyl group, the C double bonded O, but unlike with the aldehyde, the carbonyl group carbon is bonded to two other carbons. And if that's the case, then we'll call that a ketone, where the suffix at the end gets changed to ONE, or own. And if our carbonyl group carbon is instead also single bonded to an oxygen that's single bonded to a hydrogen, sort of like a carbonyl group where the carbon also has an alcohol group. Altogether, that's called a carboxylic acid group, and when we see that, our suffix changes to OIC acid or oic acid. For the first two examples where we have less than 3 carbons, we can't have a ketone, but let's look at the other two functional groups. If we have an aldehyde, well, let's say we have a 1-carbon molecule. If that 1 carbon is double bonded to an oxygen and is bonded to at least 1 hydrogen, then we can call that methanal. The root word being methane, where we change the E at the end to methanal. The methan means a single carbon unit or a single carbon molecule. Now, if that carbon instead has a carboxylic acid group, we'll call that methanoic acid. And to admit, this carbonyl carbon, that carbon double bond to oxygen, it is single bonded to an hydrogen, so you can think of this as an aldehyde group. But if we have a carboxylic acid group, it always takes priority when we name our molecules. So because there's a C double bond O, single bond OH, we'll call that methanoic acid. Methan meaning a single carbon, and an oic acid meaning a carboxylic acid group. Now, if we have 2 carbons, these are going to be molecules based off of ethane, or a 2-carbon molecule. If one of those carbons has our aldehyde group, then we'll call that ethanal instead of ethane. And if we have the situation where we have 3 or more carbons or 2 carbons and a functional group, we can then represent these molecules as line structures, which basically just means we draw our carbon backbone as points that we connect with lines to represent the chemical bond between those 2 carbons. So 1 point here for the 2 carbons with a bond here. And we just don't show the bonds that go from carbon to hydrogen. Carbon has to be bonded 4 times, and this carbon here represents this carbon, which is single bonded to another carbon and bonded to 3 hydrogens. Just to save up on space, we're not showing those 3 remaining bonds to hydrogen. If we have a carbon in our line structure where we don't see 4 bonds, we just assume that the remaining bonds are to hydrogen. If we have an aldehyde, you can show the bond from our carbon to the aldehyde hydrogen, or you can leave it out, but we will have to show that we have a carbon that is double bonded to oxygen. And be careful, don't forget that we have our carbon-to-carbon bond, and then we also draw a bond to our functional group, in this case our carbonyl oxygen. If we have our 2-carbon molecule, where one of those carbons has a carboxylic acid group, then we can call that ethanoic acid. Ethan meaning 2 carbons, and then oic acid meaning a carboxylic acid group. And we can then draw the line structure like shown below. Let's say we have 3 carbons now, and as we're getting more complex, we have our carbonyl group, the C double bond O, is at the end of our molecule, and that carbon is also bound to a hydrogen. So we can call that an aldehyde molecule. Because there's 3 carbons, that's based off of the molecule propane, and because it's an aldehyde, we change the E to Al to have propanal. Not to be confused with the molecule propanol, which has an OL at the end. The OL means that we would have an alcohol group or an OH hydroxy group. If we now have 3 carbons and the carbonyl group is in the middle of our molecule or in one of the interior carbons, we now have what's called a ketone group, or a carbon double bonded to oxygen, a carbonyl, that is also bonded to 2 other carbons. Because there's 3 carbons in a molecule, we call that propan. But instead of propane, we now call it propanone. Just make sure that if you draw the line structure, you draw your carbon backbone, and then you also include the double bonded oxygen on the appropriate carbon, in this case, the middle carbon. And if we were to have a 3-carbon molecule where one of those carbons is a carboxylic acid carbon, we can then change the name to propanoic acid. Let's say we now go to 4 carbons, or a 4-carbon molecule, and it doesn't matter if the aldehyde group is at this end of our molecule or at the other end of our molecule. Just matters that we have a aldehyde group. It's 4 carbons long, so coming from the word butane, butan meaning 4, we'll add the al suffix at the end for butanal. And to represent the line structure, 1, 2, 3, 4, and then we have our aldehyde group. Formerly on the first carbon, actually. If one of these interior carbons has the carbonyl group, then we can call that butanone. And as you draw the line structure, just put it on one of the appropriate interior carbons. If you drew the line structure, it wouldn't matter if you put the carbonyl oxygen bonded here or here, because it would actually still be the same molecule. And we have 1, 2, 3, 4 carbons. Carboxylic acid group being the first carbon, 1, 2, 3, 4. We could then draw a line structure like so, and we would call that butanoic acid. One last example. Let's say we had the situation where as we get more and more carbons, aldehydes don't change, the carboxylic acid doesn't change, those functional groups always show at the very edge of a molecule, at the very edge of our carbon backbone. But what if we had more than 5 carbons? In other words, more than 2 carbons in the interior of our molecule, and we had that carbonyl group, say, on this carbon, or in the direct middle, or say more toward the other end. Well, here's the thing. For this class, if you have me as a professor for General Chemistry 2, just call it pentanone if it's 5 carbons long. If it's 6 carbons long, you would call it hexanone. If it was 7 carbons long, heptanone, octanone, nonanone, or decanone if we get up to 10 carbons. It doesn't matter if the carbonyl is slightly at the edge of our interior or directly in the middle. Just count out the number of carbons. Use that as your root word, so pentan for 5, and then end it with the ketone ending -one for pentanone each and every time. That's good enough for this class in general chemistry as an introduction to organic chemistry naming. Formally, the way that we would tell the difference between this molecule, and this molecule, well, let's count out the carbons. 1, 2, 3, 4, 5. The ketone is on carbon 2. So in actual organic chemistry, instead of calling it pentanone, to be more specific, we would call it 2-pentanone. In the case of our middle molecule, 1, 2, 3, carbon 3 has the ketone group, we would call that 3-pentanone. And then on the molecule on our right, well, let's count the carbons. 1, 2, 3, 4, 5. If we count from left to right, carbon 4 has the ketone. Or if we count from right to left, 1, 2, 3, 4, 5, carbon 2 has the ketone group. In that case where you have more than one option, choose the option that has the lowest number. So the molecule on the left and the molecule on the right would both be called 2-pentanone, because they are in fact the same molecule. For general chemistry though, as an introduction to organic chemistry, just be able to know that a 5-carbon molecule with a double bonded oxygen in the interior would be called pentanone. For organic chemistry, that's when we start having these prefix numbers to help distinguish different types of molecules in the same general functional class. And then we could continue on for, say, molecules with 6 carbons, which would be hexanal, hexanone, hexanoic acid. 7-carbon molecules would be heptanal, heptanone, heptanoic acid. 8-carbon molecules would be octanone, or octanal, octanone, or octanoic acid. 9-carbon molecules, the root word being nonane, we would have nonanal, nonanone, nonanone, Na, let's see, nonanone, Nona, None, or nonanoic acid. And then if we had a 10-carbon molecule, it would be from decane, so decanal, decanone, or decanoic acid. And in any case, that should conclude this part of our organic chemistry functional group naming series. So just around the 12.5-minute mark. Glad to have you all. Likes and subscribes are never necessary, but are appreciated and may help the channel grow to some interesting levels. Whatever the case, glad to have you all, and peace.